Sir.
Okay, copper wire diameter, resistivity, then to this with the resistance. How much is the resistance change? The diameter is double without changing its length. Okay. Okay, they are given the diameter. PS 0.5. Resistivity is given. Okay. Calculate the length of the wire. So resistance to the formula, right? R equal to rho into L by V. Okay. Resistance is given 100 ohms, right? So this should be 100. 100 equal to rho is SI units 1.6 into 10 raised to minus 8. You have to find L. And the area is pi r square, which is same as pi by 4 e square. D is 0.5 mm, that is 0.5 into 10 raised to minus 3 square. It is 14 denominator. Okay. You just have to do the calculation.
Sir, how does pi by 4 come, sir?
Just a minute. Area of a circle is pi r square,
Pi
right?
r square.
And r I can replace as b by 2. This 1 by 4 or pi by 4. D square. Is that clear?
Okay, sir.
Or you can find r and then use pi r square. Both are same. Okay, so this you have to simplify. This is 1.6. Pi is down. 4 will go up. Okay. 0.5 square is 0.25. Into 10 raised to minus 6. So these two will cancel. So 6 will come.
Sir, your voice is a bit low.
Yeah, this is minus 2. So this is simple calculation you yourself can do. So 10 into 100 pi into 0.25. So it becomes 25 pi, right? So this 100 into 0.25. It's 25. Okay, 25 pi by 4. 10 decimal becomes this 100 divided by 1.6. to 0. Okay, so we can do it approximately. This is the will go 25 times. Looks like the answer is wrong. Rho is incorrect, right? 100 equal to this is 100. Rho is 1.6. Well, by a 5 by 4 e square 5.
சுஜி பட்டு வச்சிருக்கா அதான் வாங்கினேன்.
What answer they are getting? So everybody get this answer? This one. Actually, this
Sir, could you please explain it again? I can't
Yeah.
understand.
I'm not simplified it. So this is coming out to be 1200. So I'll just get the answer and explain it. 25 square is how much? 20 square is how much? 625, right? Yeah. 625 into 5 divided by 1.6. 1.6 is 16 by 10. When taking class in the school, yes, Wi-Fi is bit slow. 625 to 5 years 3.12 divided by 1.6. 1226. Point something meters. Okay. So, Varun, are you getting this answer?
Sir, yes, sir, but the answer is 1200, sir.
1000?
200, sir.
Okay, the book answer is correct. Question number what? 21, right? Okay. Okay, who has got doubt? I'm explaining the question again. Copper wire, okay, diameter is given as 0.5 millimeter. Resistivity is this much ohm meters, which is SI units. So calculate the length such that the resistance is 100 ohms. You have this relation, right? R equal to rho into L by A. So R is given as 100 ohms. Rho is given.
I have doubt, sir. While calculating the length, we have to double the diameter also, sir.
What calculating the length? What you have to do?
Oh, sir, while trying to find L, do we have to double its diameter?
No, you have to find the area.
Oh,
You have to
okay.
find- You have to find area, right? That is pi r square, which is same as pi by 4 d square. Since they are given d, I'm using this formula. Okay, so pi by 4, d is 0.5 into 10 to the minus 2 because millimeters, right? So square. So this one 1.6 really okay, 5. 4 will come up. 0.5 square is 0.25. 10 to the minus 2. 10 to the minus 2. Okay, so L is 25 5 by 1.6. 4. What is this minus 2 is 25. This 25 square 5. Twenty-five square is 625, right? 25 by 1.62. This one. So 25 5. Okay, calculation you have to do. Let me check whether there is some mistake here. So this is the method. Okay, so with this you
Sir,
should
I
get.
have a doubt, sir.
Yeah,
Sir, the 44th question, I can understand the steps they have in the
which step you didn't understand?
44th question.
Hold on, let me finish this one. Second part is there, no?
Okay, sir. Okay.
So in the second case, how much the resistance will change if the diameter is doubled without changing the length. So D is given, L is given. So second case D is doubled. So area will become 4 times. Okay, we can do the area in the second case is 5 by 4. Second case diameter D2 square, that is diameter is doubled, no? So what I want to say is this is same as 4 times the previous area. Okay, and length is same. Length is not changed, diameter is doubled. Okay, so resistance become when the area is increased, resistance will decrease. R equal to rho into L by A. So all the things are fixed, only the area is going up by 4 times. Okay, so resistance will go down by 4 times. So the second case resistance will be the first case resistance, which is 1200 by 4. This many points. So this is 300 ohms. And this doubled. Area is 4 times. Okay, now resistance is fixed to 4 times of the resistance. It's 1/4 of this one. That's 300. No, sorry, resistance is how much? 100, right? It's correct. Made a mistake here. The resistance value is going down 1/4. The original resistance is 100, not 1200. So it will become 25. Okay, whenever the area goes up, resistance will go down. Because area is the denominator, right? If the length is going up, resistance will go up. So here the area is going up 4 times because diameter is doubling. Okay, since the area is going down 4 times, resistance will, sorry, area is increasing 4 times, so resistance will decrease 4 times. Because area is the denominator. If the area is more, it's easy for the current flow. So I'm getting doubts only here. I'm not getting this number. I'll check and tell you. Okay. Is it clear, Varanian?
Yes, sir.
Okay, next is question number 44. This one. used to half of its initial value doing so with the other parameters executing and change. Yeah. So the resistance is there. So resistance is reduced to half. Right? So R I'm reducing to R by 2. Okay. So basically the resistance will be connected across a voltage source. It will be fixed. Okay, right? So whatever is the resistance value, okay, so we can write the dissipation here, resistance as E square by R, because what is fixed is
Sir,
P is fixed. Hold on, I'll explain. See,
sir, can you
this
please talk a little more louder, sir?
this resistance will be connected across a voltage source, right? So this is the voltage source. So this voltage is fixed. Okay. So once the voltage is fixed, for power we have three formulas. One is P into I. Okay, that is same as I square R. That is same as V square by R. This is by using Ohm's law. Because P by I equal to R. Okay. So here in the second, the resistance change, this current will change. So in that case, I have to find I2. The resistance value is R2. Okay. So I have to do I2. That also I can do. I2 will be same V. V is not changing by R2. Okay. So R2 is R by 2, right? So current will increase 2 times. Okay. But so when current is increasing 2 times, use this formula. I square R. The power will go up 4 times. So P2 is 4 times the previous power dissipation. Okay. Or I can extend use this formula because V is fixed. Since V is going up, sorry, R is going down half, power will double. Sorry, power is not going up 4 times, it is 4. The resistance is changing, right? Mistake here. Power in the second case, because of the current doubling, there will be a factor of 4. After that, resistance is reducing to half, right? There will be a factor of half. So times P1. So power is basically twice the initial power in the first case. So this answer I can get also from using the formula of V square by R. Because V is fixed. Okay. V is fixed because the voltage source, that voltage will not change. Here R is going down half times, power will go up 2 times. So the only catch in this problem is you have to use this formula. Because for a voltage source,
Okay, sir.
V is fixed. So it will be easy to use this formula.
Okay, sir.
Let's go. Yeah, here they use I square RT. Then you have to find I and R. So I is changing by some factor, R is reduced by half. So you have to multiply these two to get the change in the power dissipation. So you can straight away use this for the all this simple. Is it clear? Someone is chatting? No. Okay. Any other doubts? In light chapter or electricity chapter?
No, sir.
Okay. So in this human eye part, in this chapter, what I want to do today is a combination of the eye, accommodating power of the eye. So just to recollect what we studied in the last class. So what do you think is the main difference between the lab lens and the eye lens? lab lens, for example, okay, so since eye has got a convex lens, which looks something like this. Okay. And lab lens have to compare with convex lens only, because this is a convex lens. So the corresponding lab lens is the convex lens. The difference between these two is this is rigid. The shape of the lenses will not change. So the radius of curvature of this part R1 and the radius of curvature of this part R2 is fixed. Once R1 and R2 are fixed, the focal length is fixed. But for an eye lens, this is a flexible lens. The focal length is variable. It's a flexible lens. Okay. So, but what is fixed in this eye lens? Anyone? If I write the
So
lens,
we fixed.
that's right. So if I write the lens formula, is 1 by 2 with a minus sign plus 1 by b equal to 1 by f. For the lab lens, f is fixed because it's a rigid lens, and u and b are the two variables. But for the eye lens, b is fixed, which is the distance between the retina and the lens. That cannot change. Okay. Since b is fixed, I have to change focal length for different objects. I can also see nearby object, also far object. Okay. So let me go through this NCERT text. So eye lens is composed of fibrous jelly-like material, this flexible material. Its curvature, because lens you will get by having two spheres intersecting. A convex lens is nothing but you have two spheres. Okay, this intersecting part is the lens. Okay, but if the radius of this sphere, which is R1, and the radius of the second sphere, say R2, both are fixed, means the focal length is fixed. So the curvature of this part is basically R1. The curvature of this side is R2. Okay. So that's what is meant to be the curvature of the lens. Okay. This is the curvature of the lens can be changed to change its focal length. Okay. When the muscles are relaxed, the lens becomes thin. So this eye lens so these are the muscles, right? So this muscles can either stretch or relax to stretch this lens. Okay, the lens, if the lens gets stretched, the thin lens, so focal length will be more. If it contract means focal length is reducing. Okay, so focal length decreases. So muscle is relaxed means lens becoming thin. So focal length decreases. This enables us to see objects clearly. So objects closer to the eye. Okay. One more thing is the lens formula is one by u plus one by v equal to one by f. And for a convex lens, or even for mirror, or even concave lens, the object is on the left side. Okay, this is the positive direction. So u is always negative. Okay, always. So minus u is positive quantity. So this term is a positive quantity. Okay, so the object is coming closer to the lens. Minus u is decreasing. Okay, so that means the first term is increasing. Okay, and the object is coming nearby. Okay, the first term is increasing, and this is a fixed quantity. So this also has to increase. That means that the focal length has to decrease. Let me repeat. As the object is coming nearby, okay, minus u is decreasing, okay. So the first term will increase. This second term is fixed because p is fixed. So this right hand side should also has to increase. That means the focal length will decrease. So when nearby objects, focal length has to decrease. That means the lens should look like this. We have fat lens. Far away objects, okay, the focal length has to decrease. So the lens will become thin. This is done by the ciliary muscles. Okay. Closer to the eye, increase the curvature of the lens. So closer means the curvature is more. Curvature is more means it's a smaller radius. Okay, the focal length is less. Focal length decreases. Okay, for far away objects, it's a thin lens. Yeah, this is important. Because these muscles relax, lens is thin. Okay, focal length is large, increases. So this enables you to see the distant objects clearly. So to see nearby objects, the curvature of the lens has to increase. But with the thick lens, the focal length will decrease. Okay. So this ability of the eye lens to adjust the focal length depending on the object distance is called accommodation. Basically, the eye is accommodating for the object distance by making it flexible. Okay. But if the object gets too close to the eye, so this is the eye, have eye lens here, and the object can be here or here or here, but you cannot see it. As it gets closer and closer, the focal length has to decrease. That means the lens has to become fatter and fatter. But it cannot, I mean, this going on can happen only up to a certain extent. Okay, so this thing, if it gets too close to the lens, then it will not, focal length will not adjust to that level for the image to be seen properly. So this minimum limit up to which it can adjust the focal length for the image to be seen clearly is 25 centimeters. So for a normal eye, if you place an object at 25 centimeters or beyond it, you can see clearly. Within this, even a good eye will not able to see. So this 25 centimeters is for least distance of distinct vision. Okay, and the maximum distance the normal eye can see is it's infinity because you can see the moon, sun. If you are careful, you can see. Okay, so as such, normal eye, the far object is there is no limit. So for a normal eye, the range of view it can be greater than 25 centimeters, and there is no limit to the maximum distance you can see. Okay. So this is a normal eye. So the farthest point up to which I can see is far point, it's called far point, and is infinity for a normal eye. Okay. And 25 centimeters is the minimum distance you can see. Minimum distance. If the object is within 25 centimeters, even a good eye not be able to see. Another problem with the eye or the eye lenses, as you get older, this eye lens will not become not be a perfectly transparent material. It will become a little bit opaque. That's what they mean by milky and cloudy. Okay, so this condition is called cataract, and it can be removed by, it can be corrected by surgery. So any questions in this one? Basically, the object distance as it changes, the focal length has to change, but this focal length, as the object gets nearby, the focal length has to keep on reducing, but there is a limit to which the eye can adjust its focal length. So that is the object distance cannot be less than 25 centimeters. Okay. That is the limit of a good eye. But the far away distance object can see even very distant objects like moon and the sun. So far away object there's no limit. So for a normal eye, the range of vision is 25 centimeters to infinity. And this maximum distance point, this is called the far point of the object or the eye. This infinity is called far point, which the eye can see. And this 25 centimeters is near point. Near point for any other with normal vision is about 25 centimeters. Okay, and far point is take a snap. Right, so this is what we've done so far. First, this is a human eye, the different parts, what are the function of the different parts of the eye. Okay, and today I have talked about this accommodation of the eye, which is basically the ability of the eye to adjust the focal length so that the eye can see objects from 25 centimeters to infinity. Okay, and one more concept is there. What will happen instead of two eyes if you have only single eye? Suppose you have only one eye. This is the eye. Okay, right, that's eye. Okay, and there is object here. As I increase the distance of the object or decrease it, as the distance of the object is increasing, the intensity of the light will or the image will go down since it will become some sort of a dim object. Okay, but if you have a second eye, you got the eye two. The same object I can see at a different angle, right? Once the meeting cuts, you have to rejoin again. we consider point object. Here, okay, this is a point object. So this side, you see the object, okay, and this also you see the image of this object. Okay, but suppose increase the distance of the object from here to here,